Welcome to the lesson 4, 9.34 geometry. Let's get right into things. We've got one basic new idea, the converse of the Pythagorean theorem, and make sure you're using those extra examples in your book for some extra things to look at for some help. So let's get into it here. I'm going to draw some lines here. We're going to break this first part up into 3 theorems, but they're very related to each other, so I'm going to put them all in the same place. So make a table kind of like this, and then up here we will start with the big kahuna for this lesson, the converse of the Pythagorean theorem. And then this is theorem not 5 but 9.5. There we go. This is theorem 9.5. Here we're going to put theorem 9.6. This one doesn't have a special name. And here we're going to put theorem 9.7. Okay. So the converse. Pythagorean theorem itself says that this, if you have a right triangle to start, then leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. So we're reversing this. We're going to say now, if this first part is true, if a squared plus b squared equals c squared, so two smaller numbers added together, squared and added together, equals the third one, the biggest one, squared, then you have a right triangle. That is what the converse of the Pythagorean theorem says. So let's in here draw something that looks like a right triangle. We can't assume off the bat that it is, but it may look like it. And so let's put A, B, and C here. As we go through this lesson, A and B are going to be the two smallest numbers, and C is going to be the biggest number. C may be the hypotenuse, but only if this can be proved to be a right triangle. So if a squared plus b squared does in fact equal c squared, weird equal sign there, let's fix that, does in fact equal c squared, then it's a right triangle. By it I mean this triangle up here. So then it's a right triangle. Theorem 9.6 is similar to that, but you might have a triangle that looks like this. Notice this is not quite a right triangle. They might make it look like a right triangle, though. That's probably what you're going to see, but this one I'm going to draw it in such a way that it doesn't even look like one. But if this is the case, you'll see how it's related to the converse of the Pythagorean theorem right here. If c squared is less than a squared plus b squared, if this is the case, if c squared is less than a squared plus b squared, then it is it's an acute triangle. So I'm going to underline acute here, underline right over here, and then finally you may have a picture that looks something like this. This one is kind of exaggerated. It's easy to tell that that would actually be obtuse, at least based on the looks of it. But let's say that if this is true, so if c squared now is greater than a squared plus b squared, then it's an obtuse triangle. And I think I want to change one thing here. The more I'm thinking about this is fine to write it this way, but I think it's going to be better if we write it in this format to start, so that they all look the same. They all can be compared in that same way. We can kind of see how these are all similar to each other. Just the only variation is the equal sign, the less than sign, and the greater than sign. I didn't mean to say less than or equal to. If it's equal to, it's a right triangle. If it's less than, it's an acute triangle. If it's greater than, it's an obtuse triangle. And that kind of makes sense too, because acute angles are smaller, the c squared is smaller. Obtuse angles are larger, the angle is larger, and c squared is larger. So that matches up kind of with our hinge theorem and the converse of the hinge theorem. If the angle gets bigger, the side across from it gets bigger. If the angle gets smaller, the side across from it gets smaller. So there's a nice connection there with that too. So there's a couple steps to go through when you're doing problems like this. And if you follow these 2 steps, you're going to be golden. You're going to be good to go. So to decide if a triangle is acute, obtuse, right, or not a triangle. So I guess technically I should say to decide if something is acute, obtuse, right, or not a triangle, if a shape is, if a 3-sided shape, or if you're given side lengths, if it's even possible to make it a triangle. But I think for what we're talking about here, this is probably the best way, or the easiest way to think about it. So, or not a triangle, follow these steps. 2 steps. Step 1, first you need to check if the 2 smallest sides, a plus b, added together, a plus b, is greater than c. In other words, or you can say i.e., that's meaning the same thing as in other words, c, if the 2 smallest sides add up to more than the 3rd side. If yes, then let me rephrase that. Let's say if no first. So if no, it's not a triangle. And you can stop right there. It's not a triangle. If yes, so no and yes. If yes, we need to check what kind of triangle. And so over here I just drew something. I just paused it and put this in here because I wanted to make a point about this, like what do you actually mean by this, Mr. Wagner? So say that the red side and the green side, these are the 2 smallest sides. If this is not bigger than this blue side, so say for instance, let's just give this labels. Again, don't draw this. This is just to help you understand what's going on here. So let's say this blue one was 10, and this red one was, we'll go with 5, and we'll say the green one is 3. If you try to connect those, there's no possible way to connect those. If we rotated this around or down to here, it's going to land right about there, right about halfway. That's a kind of a rough drawing here. And then the 3, you can't possibly connect those 2 sides. There's going to be this gap of 2 left over. But if I change this in such a way, so that in such a way, change this so that these sides become longer. So let's say now I'm going to make it 7 and 5 instead. So suddenly this changes to 7, this changes to 5. I have something that's big enough to actually touch then right here. Oops. So it's actually big enough to touch, to connect right here and right here. So as long as this plus this is more than the longest side, a plus b is longer than the other side, the long side of the triangle, potential triangle, then you actually can make a triangle. But if not, then you can't. So I'll leave that over there, but you don't have to write that down. But step 2, definitely have to write this down. Step 2, to check what kind here we're going to compare, put c squared first. If you put c squared first, this will make it really easy. So I don't want you to put a squared plus b squared first. I want you to put the c squared part first, put a blank and a question mark, and we're going to compare that to a squared plus b squared. If they are equal, then you have a right triangle. If it's less than, then you have an acute triangle. If it's greater than, you have an obtuse triangle. Forgot to underline that. Let's underline that there. So let's do some examples now. So example 1 here, we're going to decide I'm going to say it's instead of a triangle. So decide if it's, because maybe it won't be a triangle at all. So decide if it's acute, obtuse, right, or not a triangle. So I'm going to draw them to look like they actually are triangles, but we're going to decide if that's even a possible picture. So here's a couple examples to start off with. I don't want to use green there, I want to use black. Let's try that again. So that should do it now for me. And I'm not going to make these look like right triangles necessarily, or like anything necessarily. This might be a right angle right here, you don't know for sure. And so this one I'm going to go like this. Maybe it's a right triangle, maybe it's not. Most of the time they're going to draw them so that it kind of looks like there's a right angle here, it kind of looks like that might be a right angle there, but we can't make that assumption. We actually have to check it out and see for ourselves. So let's say this is 13.4, this one's 10, this one's 7. So notice no right angle degree mark there because I don't know for sure. And there's no right angle mark right there because I don't know for sure on this one either. So I'm going to say this is 6, 12, and 6 radical 5. And so let's do our steps. So make it easier on yourself. Just do the 2 steps. Just go through these 2 easy, simple steps and you'll get the right answer every time. So step 1, let's check a plus b and see if it's bigger than c. So the 2 smallest sides, 7 plus 10, is that greater than 13.4? If we add 7 plus 10, we get 17, and that is greater than 13.4. So I'll put a little check mark there. We know we're good to go there. We actually have a legitimate triangle. And so now we need to check c squared compared to a squared plus b squared. So check 13.4 squared, compare it to, put a blank with a question mark, we don't know yet, compare it to a squared plus b squared. If it helps you to actually label your a, b, and c, you could do that too. So you could call this a, you could call this b, call this c. I usually just go in order of the numbers. A and b can be interchanged, but c has to be the biggest side. So take out a calculator at that point, because I don't think most of us know 13.4 squared off the top of our heads. If we check that out, we get 179.56. So we have 179.56 right here, and we're comparing that to, and I'm still going to put a question mark here, comparing that to 49 plus 100. Now you might look at that and say, oh, I know what that is. That is definitely, this side is bigger than that side, and you would be correct if you say that. So this is now greater than. I'm getting rid of my blank. I'm not going to put greater than or equal to. That's not the case. It kind of is the case, but we want to check, is it strictly greater than, or strictly less than, or actually equal to. So this is strictly greater than 149. So that means, based on what we had here, the c squared part is larger, it's obtuse. If the c squared part would have been smaller than a squared plus b squared, it would have been acute. So our answer here is, we have to do this work to verify it, but our final answer is obtuse. And then over here, we check, first of all, to see if it's a possible triangle. So to know what the longest side is, honestly, we have to look at this and say, what is that as a decimal? So let's put that approximation over here. We have 6 times radical 5, which is, okay, so this is about 13.42. I'm going to put this in parentheses because we don't want to use this in our calculations. We want to use the exact number. But just to see what A, B, and C are, we need to actually do something like that to make sure that this is the longest side, and in fact it is. So here's my A, here's my B, here's my C. So I want to check and see, is 6 plus 12, is that greater than 6 radical 5, which is about 13.42. 6 plus 12 is 18. Is 18 more than 13.42? Yes, it is. So we can move on to step 2. So step 2, we need to check now c squared. So plug in the exact number. Don't plug in the decimal approximation, because then it won't be what it exactly is. We need to check this exactly for what it is. So put a question mark there. We're not sure yet. What is that compared to 6 squared plus 12 squared? So let's work this out. This is the same as, you can kind of think of, in a sense, like we're distributing the power to the 6. We're distributing the power to the radical 5. So this becomes, in a sense, this becomes, I'll do that there to kind of demonstrate that. This is 6 squared times radical 5 squared. What is that compared to 6 squared is 36 here, 12 squared is 144. So what is 6 squared? That's 36. And what do squares and square roots do to each other? They cancel each other out. So we have 36 times 5 is question mark, I don't know, compared to, this adds up to 180. What is 30 times 5? That's 150. What's 6 times 5? That's 30. So we have 180. What is 180 compared to 180? It's equal to 180. And so what do we have here? Go back to our theorems. This one is equal. So we have an actual right triangle. So if I wanted to at the end, now I could add this in. I'm not going to do that here, but I could, maybe in a different color, I could add in that that was in fact a right angle right there. We have a right triangle. And so let's practice a couple more of these, but this time I'm not going to draw the triangle. I'm just going to give you 3 side lengths, and we're going to decide from there what we think. So the same thing as before. To start, decide if it's right and why don't I just keep this consistent with the way I had it before. So decide if it's acute, obtuse, right, or not a triangle. So let's write that the same way. Decide if it's acute, obtuse, right, or not a triangle. And so let's say I give you 3 side lengths now. Here are your side lengths. This is kind of like part 1 of this example 2 here. So side lengths, let's say they were 8, 18, and 24. Got to do step 1 first and check and see, is this actually bigger? So take the 2 smallest sides, that's your A and B, so the 2 smallest sides here are in order already. Is that greater than 24? 8 plus 18 is 26. 26 is in fact greater than 24. So that's good to go. So we'll check step 2 now and compare c squared, 24, compare that to a squared plus b squared, 8 squared plus 18 squared. So these are my potential legs, the A and the B. This is my potential hypotenuse, but only if they're equal to each other. So if I take this, I get 576 is 24 squared. And if I check this side out, I've got 8 squared, which is 64, and I've got 18 squared, which is 324. So just looking at these 3 numbers right away, wasn't totally sure what kind of triangle it was, but now that I'm getting closer here, it seems to me that this is going to be much bigger than this, and in fact it is. So this is greater than, if you add these things together, you get 388. And so what's the answer here? What kind of triangle do we have? This is clearly an obtuse triangle, because c squared is greater than a squared plus b squared. So let's do the same thing with a couple more examples within this example. So let's say we have side lengths of 3.2, so we're going to use some decimals here, 3.2, 5.1, and 4.8. So go through your steps. Step 1, what do we got here? Look for the longest side. The longest side here, I didn't write these in order on purpose. I wanted to see if you would catch that. Here's the longest side. This is going to be your C. If it helps you to label, go ahead and label. So if If you want to say that this is A, B, and C, do that. If you want to say this is A, this is B, and this is C, let's do that here. So let's put this in a different color. I'm actually going to do that on this one. So this is A, this is B. The two smallest sides are A and B. The longest side is C. In this case, the longest side is in the middle, which is fine, but we just have to recognize that. So is this true? Does A plus B, this plus this, is that bigger than 5.1? Is that actually true? Is it greater? So this plus this is 8. 3 plus 4 is 7. 0.2.8 is going to be 1. So is that more? Is 8.0 bigger than 5.1? Sure is. And so let's check now step 2. Compare c squared, 5.1 squared, compare that to a squared plus b squared. So 3.2 squared plus 4.8 squared. So take your calculator out at this point and let's check those things. So 5.1 squared ends up being 26.01. And we're comparing that to 3.2 squared. Don't know that one off the top of my head, so I'll check that out. 10.24 squared. And then 4.8 squared. All these things are, whoops, all these things are, you could take 48 squared and you get 2,304. If you take 4.8 squared, you get 23.4. 0.04, sorry. So if we add these things together, what do we have here? We've got 26.01 is what compared to these two added together? If you add these two together, you get 23. What am I saying? Whoa, not 23, but 33. Whoa, still 0.01. Get 33, there we go. 10 plus 23 is 33, and then 0.24, 0.04, that'd be 0.28. So in this case, the c squared is less than the a squared plus b squared. So we had a triangle. We checked a plus b is bigger than c, but this is less than this in this case, so this is an acute example. So cute. Cute little decimals. Okay, so don't get me wrong there. Decimals, just because they're decimals doesn't mean they're going to be acute. We have to check and go through the steps. So let's try one more example here. Let's say you had side lengths of 6, 9, and 16. And get your different color out. Are these in an appropriate order? Yeah, this would be A, this would be B, and this would be C. C is your longest side, 16 is the longest side. So let's go through the steps and see what we got. So step 1, check out A plus B and see if it's bigger than C. 6 plus 9, is that greater than 16? Before we've just kind of been like, oh, yep, we're good to go. Here though, no it's not. So we're going to put a little slash through that. This is not greater than 16. Therefore, we don't need to do step 2. There's no reason, there's no point in doing step 2 because we can't even make a triangle with this. So if A plus B is not greater than C, going back to our steps here, if no, it's not a triangle. So we're done in this case with that one. So we would say not a triangle. So wanted to throw one of those examples in there just to show you one that would not be a triangle. So that's all for this lesson. Hopefully you found that helpful and can use this and the examples in your book to help you do your classwork and do that really well.